Voyager 1, NASA's farthest away thing we've ever made, has amazed people around the world for almost 50 years. Since it took off, it sent back key info from deep space, helping us learn a ton about the universe. But lately, it's been sending weird signals that are confusing scientists. These strange blips have caused a lot of chatter, with people wondering if it's just a glitch or maybe something totally out there, like aliens. Come check out these puzzling messages and see what secrets might be hidden in space. We've always been driven to solve mysteries, which is why we explore space. This interest led to cool projects like Pioneer 10 and 11, which were super bold for their time. Then, on August 20th, 1977, Voyager 2 launched from the Kennedy Space Center, kicking off a whole new time for space science. Not long after, on September 5th, 1977, Voyager 1 took off, starting a mission to the outer planets that changed what it was supposed to do and what it could teach us. Each probe weighed about 721 kilograms, like a small car, and traveled different paths at different speeds. By December 15, 1977, Voyager 1 was already ahead of its twin because of these separate routes. Since then, it's been a key tool for learning about space, making finds that have changed how we get the cosmos. Before we look at its more recent stuff, let's remember some early wins. In 1979, about 265 million kilometers from Earth, Voyager 1 took high-quality pictures of Jupiter. By January, it had spent 100 hours watching Jupiter, making a time-lapse video showing the planet spinning. This video, with 3,750 frames, gave us awesome details about Jupiter's crazy atmosphere and shapes. Voyager 1 also found a ring around Jupiter that we didn't know about, plus 2 new moons, adding to what we knew about the planet. To stay on track and not crash into Titan, a moon of Saturn, the probe had to adjust its course. After that, the mission changed from planets to interstellar space, moving at a crazy speed of 325 million kilometers a year. In January 1990, Voyager 1 started checking out interstellar space, going past our solar system. It did some amazing things, like spotting 4 more moons, Memes, Celadus, Tus, and Rhea, and taking some of the most famous pictures of the outer solar system. On February 14, 1990, from about 6 billion kilometers from the Sun, Voyager 1 took the iconic family photo, a bunch of pictures of the inner planets put together. These 60 images added to the hundreds of pictures it had already taken of the gas giants. Meanwhile, Voyager 2 was doing its own cool stuff. It measured winds on Neptune going over 2,100 kilometers per hour, the fastest ever seen in our solar system. It also looked at Triton, Neptune's biggest moon, which is super cold at minus 391 degrees Fahrenheit, minus 235 degrees Celsius, one of the coldest places we know. Triton seemed to have icy volcanoes, shooting nitrogen gas and frozen stuff up to 5 kilometers high, showing that it's still active. These finds really helped us understand what's going on in the outer parts of our solar system. Both Voyager 1 and 2 have done incredible things. Their info showed us stuff about Jupiter and Saturn's moons that we never knew. We thought they were just dead rocks, but they're actually active. Voyager 2 is also the only probe to fly by both Uranus and Neptune. To keep these missions going longer, NASA got creative, like turning off some systems to save power. They plan to do this until 2030, which will be the end of this epic trip. Voyager 1 and 2 were built with top-notch tech. They were made to spin slowly to keep pictures clear as they traveled to the far-off planets. The probe started sending back detailed shots of Jupiter, showing its swirling clouds and the Great Red Spot, a huge storm that's been around for ages. They also spotted active volcanoes on Io, one of Jupiter's moons. Instruments on board picked up weird signals, and then pictures showed massive volcanic plumes and changed ground. One eruption on Io was said to be 1,000 times bigger than Mount St. Helens, covering an area the size of France. As the missions went on, both probes were slowly powered down to save energy before going into interstellar space. But they couldn't take pictures of Mercury or Mars because of tech issues. NASA then launched other awesome missions like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed Pioneer 11 as the farthest spacecraft from Earth. But Voyager 1 kept going for another 14 years, officially entering interstellar space on August 25, 2012. A big part of their success was using gravity to boost speed and change directions, saving fuel. Instead of just using engines, they used gravity to speed up and move around. As Voyager 1 got close to Jupiter, the planet's huge gravity pulled it forward. Precision was key to avoid bad changes in speed or path. These gravity tricks let the probes travel through the solar system. Voyager 2 also used Jupiter and Saturn's gravity to keep going towards Uranus and Neptune, showing how well this works. Looking back at these amazing missions, scientists are now excited about what Voyager 1's weird signals might mean. Both spacecraft are still working far outside our solar system, still checking out the mysteries of Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse videos caught 10 eruptions on Jupiter and found new moons and a ring around the planet, really growing what we knew about Jupiter. Voyager 1 also found 4 more moons orbiting Saturn, Memes, Enceladus, Tethys, and Rhea, and sent back stunning pictures of the planet and its rings, showing their detailed design. Its trips to Uranus and Neptune gave us key info about their atmospheres and moons, growing our knowledge of the outer solar system. After flying by the gas giants, both spacecraft headed for interstellar space, where they keep sending back helpful info. This ongoing mission grows our view of what's beyond our solar neighborhood. As we wait for updates on Voyager 1's strange signals and what they might mean for how we understand space, these amazing trips continue to inspire scientists and space fans alike. Their story is important for growing human knowledge and pushing the limits of space science. The Voyager program has given us unique views of our solar system from beyond its edge, with famous pictures and important science data. The probes also carry a message for any smart aliens out there, the Golden Record, with greetings in 55 languages, music from different cultures, and natural Earth sounds like thunder and whale songs. This interstellar greeting is a hopeful message from humanity to possible life beyond Earth. Voyager 1 and 2 have a bunch of instruments that have really improved our understanding of space. These include magnetometers, plasma wave detectors, and imaging devices, all gathering key info about space. The magnetometers showed us the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, explaining how they interact with their surroundings. Plasma wave instruments helped us see how solar wind affects planetary atmospheres. One highlight was finding the boundary of the heliosphere, a big area filled with solar particles and magnetic forces surrounding our solar system. As Voyager 1 got closer to this edge, it recorded the change from solar wind to interstellar medium, giving us insights into how this protective bubble keeps Earth safe from cosmic radiation. The spacecraft found the termination shock, where solar wind slows down and gets squeezed. Beyond that is the heliosheath, a messy place where solar and interstellar particles mix, making things complicated. Voyager 2's mission also really boosted our understanding of the outer solar system. Its close flybys of the giant planets gave us key observations, especially about Uranus's magnetic field, which was tilted in a weird way, going against what we thought. These finds have led to more research into planetary magnetism. These missions didn't just grow science, they also got folks excited about space exploration again. The amazing pictures of far-off worlds and the thrilling stories have inspired people. Iconic images like Saturn's beautiful rings and Jupiter's volcanic moons have become symbols of space exploration, encouraging newcomers to study science and chase adventure. As Voyager keeps sending cool data, its trip into interstellar space offers an awesome chance to figure out how the universe works. While earlier missions focused on planets, checking out the interstellar medium has shown us surprising details. Areas we thought were empty are actually active, testing current scientific ideas. One of the coolest finds is cosmic rays from beyond the solar system. These high-energy particles moving close to the speed of light give us clues about what's happening in distant parts of our galaxy. By looking at their energy and what they're made of, scientists hope to learn about how stars form and how galaxies act. Also, as Voyager 1 and 2 go deeper into space, their instruments keep checking the density and flow of the interstellar medium, the thin mix of gas and dust between stars. This stuff interacts with the solar wind and helps shape the heliosphere. Their data lets researchers copy how matter and energy spread across the galaxy. The Voyager missions have also shown important details about magnetic fields and interstellar space, lighting up their details and effects. These findings could eventually lead to breakthroughs in figuring out galactic magnetism. Studying these remote areas doesn't just grow our knowledge, it also inspires the next group of astronomers and engineers. The famous images from Voyager, especially the pale blue dot showing Earth from over 6 billion kilometers away, remind us that we're just a tiny part of the universe. These visuals, along with the mission science winds, have totally changed how we see our planet and its place in the cosmos. The Voyager winds have cleared the way for even more space trips. Thanks to tech made during these missions, launching fancy spacecraft to distant parts of the galaxy is becoming more real. Goals like checking out exoplanets, finding worlds like Earth, and even chasing interstellar travel are going from dreams to something we can almost touch in the future of space exploration.